Oi lads, it's Danny here today bringing you lot a lovely video on why the derivative of our cosecant of x, why is that equal to -1 divided by absolute value of x multiplied by square root of x squared minus 1. So before we jump into it, I want you lot to like and subscribe on this video and let's get right into it then. So when you're looking at this, you're trying to prove a derivative of an inverse trig function. And right away, we're not going to be using limit definition. However, we're going to be using implicit differentiation. So it's the same series of steps like we've done before, just with an additional step. And I'll show you lot what I mean by that. But the first step is the same. We're going to let y is equal to our cosecant of x. And the goal here is to isolate for this x term, so we're going to have to apply cosecant to both sides of this equation. So ultimately, once you do that, you're going to have an expression of cosecant of y is equal to x. We are then going, at this point on, we're going to then apply a derivative to both sides of this equation. The right-hand side is just going to be equal to 1. On the left-hand side, however, we got a function within another function. Therefore, we got to take the derivative of the exterior function and then the derivative of the interior function. And when you do that, you're going to have a complete derivative as shown on your screen. We are then going to isolate for this dy dx term and move everything on the right hand side basically. Once you have arrived at this stage, this cotangent of y, we're going to have to replace it with a trig identity. And the trig identity I'm referring to is this one that you see on your screen right before you. So we're going to replace the terms of y basically, and then we're going to isolate for cotangent of y. And we know that cotangent of y is equal to cosecant squared of y minus 1. And we're going to replace that into this equation right over here. Once you do that, the last step that's remaining is to replace x is equal to cosecant of y. And that basically comes from here, basically. And this is the reason why, basically, that we end up with this. But there's a thing that I need to point out is that we got an absolute value of x. Over here, we do not have an absolute value. Why is it that we need an absolute value of x? So the reason before it is if we sketch out the graph of cosecant of our cosecant of x, what you are going to notice is if you take the derivative or the slope at any point on this graph, let's say over here, and then you take it, you take it over here as well, you are going to notice is the derivative and the slope are always negative. And as a result, if they're always negative, this has to be always negative. And the x over here has to have an absolute value, making it positive, so that you're still going to have a -1 over here. So no matter if this is always going to be positive, your answer is ultimately going to be negative because you're doing a division of -1. And that's what we want basically, because it's got to match the graph basically. And this is the reason why when you take the derivative of our cosecant of x, you'll obtain an answer of -1 divided by absolute value of x multiplied by square root of x squared minus 1. So if you enjoyed this video, please drop a like and subscribe, and I'll see you a lot later.